In this example, we're going to take the integral of this function. That would be my function f of x, cosecant squared of x. So I need a function capital F of x. And what I want then is I want a function so that when I take the derivative of capital F of x, that's equal to this cosecant squared. So we have to think about our trig functions and what kinds of derivatives we have. If I had the derivative of tangent, that's secant squared. So I know if I had the derivative of cotangent x, that would be negative cosecant squared x. So what I'm going to have to do is I'm going to have to make this negative so that that becomes positive. So I'm going to get the integral from pi over 6 to pi over 4. Oh, no, I'm not going to do the integral anymore. I already know the antiderivative. The antiderivative of cosecant squared then has to be negative cotangent x, right? So negative cotangent x evaluated from pi over 6 to pi over 4. This negative can just be factored out, so I'm going to get cotangent pi over 4 minus cotangent pi over 6. Okay, so cotangent, first of all, cotangent x is equal to cosine of x over sine of x. So pi over 4 is like a 45-degree angle. So we would have our unit circle. A 45-degree angle is going to look like that. And this point has to have an x-coordinate and a y-coordinate. Well, pi over 4, a 45-degree angle, that means x and y are equal. So pi over 4, the cosine and sine were both square root of 2 over 2. So the cotangent is cosine over sine. This is my cosine. This is my sine. If I take cosine over sine, I'm taking square root of 2 over 2 over itself. Well, that's just 1. So back here, wait. Oh, this is all messed up. Let me come back here. Get rid of this. All right, do over. So negative cotangent x evaluated from pi over 6. Wait, no, I was all right. It was all right. Okay, negative. Yeah, cotangent pi over 4, the top, minus cotangent pi over 6, the bottom. All right. I could start over, but I think you can handle it. So, cotangent of pi over 4 I figured out is 1. What about the cotangent of pi over 6? Well, pi over 6 is like 30 degrees. So I've got my unit circle. 30 degrees is a shallower angle like this. So I need an x and a y. For pi over 6, then, my x-coordinate is much bigger than my y-coordinate. So my cosine is bigger than my sine. For pi over 6 and pi over 3, it's square root of 3 over 2 and 1/2. The bigger one is square root of 3 over 2. So my x-coordinate here is going to be square root of 3 over 2. My y-coordinate is 1/2. That's my cosine and my sine. And so for my cotangent of pi over 6, that's going to be cosine over sine. That's going to be square root of 3 over 2 all over 1 over 2. So that's going to be square root of 3 over 2 times the reciprocal 2 over 1, which is just going to be the square root of 3. And if I distribute then, I just get negative 1 plus the square root of 3.